Dori. I would now like to ask you about where is this going? What are some future applications for OPM that you and your team are working on?
One of the things that we already doing for a couple of years is to extend the capabilities of modeling of OPM from purely qualitative and conceptual to computational, and this is the PhD of Rea Lavi. We already can do computations of all kinds, including programming, and we are now connecting it to external software such as MATLAB and Arduino. Right. And that leads me to the next idea, which we are also working on, which is to combine hardware and software, hardware in the loop. So you start with modeling the complete system conceptually and quantitatively with OPM, and once everybody is happy with the model and it's simulating and doing what it is expected to do, you start replacing the hardware modules with actual hardware and connect it through physical connections to OPM using OpCloud. Right. This way you can continue developing the system while gradually replacing the software, the symbols or the symbols of the hardware with the hardware itself, while making sure that the system still is running smoothly. So you can think of it as a kind of an agile methodology for developing IoT, which is something that Industry 4.0 is very much in need of, and we are working in that direction.
Right, so in other words, working on Internet of Things, cyber-physical systems with OpCloud.
Exactly, and
one of the applications.
One of the things that is built naturally into OPM is the ability to model concurrently not just objects and processes, but physical and informatical things, right. Objects and processes. And simply by shading or not shading, you distinguish between whether they are physical or not. And the physical things are those that are eventually going to be replaced by the actual hardware, while the logical, the informatical ones, which are not shaded, remain as the logics of the system and become the software and the control of the system.
I see. So one application, as we said, is for cyber-physical systems.
Right.
So where you can model them, but develop, but also operate them using OpCloud.
Yes.
Any other applications?
Yes. Knowledge management is a really big direction in which we unfortunately don't yet have enough human resources to work on, but one of my former PhD students, Judith Somek, her PhD was on mRNA life cycle modeling, and we had a series of papers in PLOS One journal in which we made some discoveries in molecular biology thanks to the simulation capabilities of OPM. The problem is that she was basing her work on some 43 papers, which was central to what she was focusing on. However, there are tens of thousands of papers just on this topic and related topics, and there is no way in the world that an army of 1,000 PhDs would sit and read and tell each other about what they read. And there is not a single human being in the world, no matter how experienced and genius, that would be able to absorb all that amount of knowledge that is out there in natural language on the internet. So the only way around it is to automate the process of knowledge capturing and from the current form of natural language, which only people can understand, to modeling it in OPM. And the idea is to have a kernel of ground truth, for example, the one that we started working on, which is already very big, and gradually evolving it by mining the literature that is out there, crawling and adding fact by fact, while making sure that the facts that are incorporated gradually into the model make sense and undergo formal model verification.
Yes.
So that what you get is a huge model that connects things to each other from the molecular level up to the whole organism and even beyond. And by the way, we're also working on developing a developed query capability
Yes.
of OPM models by converting them into graph databases, which already have built-in query capabilities, and then translating it back to OPM so that the answer, the argumentation, and the explanation can be expressed in natural language. So you will have the ability to explain causalities and cause and effect, and why things that seem very remote and unrelated, what is the relation between them? They can be placed in various very remote places in the model, yet they are somehow connected, and that connection is elusive today because humans just cannot put their arms around it, but it does exist. And this way you can find out reasons for diseases that are currently not known and so on.
So in effect, what you're saying is beyond the ability to input all that information and manage all that information about a specific system or specific phenomenon, it will also allow us to identify hidden relations within a system or within a phenomenon. It will allow us to figure out how emergence comes to be in certain systems. So this is another very powerful feature of OPM potentially.
Yeah, and continuing on this line, similar to what Wikipedia did in the natural language domain, I have a vision that people will use OPM models just like pieces of information, of knowledge that are floating and are retrievable in cyberspace.
Yes.
Not just through keywords, but also through querying a certain structure of the OPM model or portions of it. And other people would be developing and putting on the internet pieces of such modules, and others could retrieve them and reuse them as building blocks like Lego. So like I said, it's actually OPM can be used as an infrastructure for knowledge management, and which is in one way formal, but on the other way very accessible because it translates to a subset of natural language.
Yes.
By the way, not just English. We can now do it in any natural language. And this is the way I would envision people, for example, expressing ideas about systems. If you look at papers nowadays, you would see ad hoc methods for depicting models or ideas which vary even within the paper itself from one sketch to another, let alone across various papers and various domains.
So this goes back to what you were discussing before, which is people use different language, different words to try to express the same things.
So because OPM really builds on the very foundational notions of objects and processes, has to do with the time space. We have 3 dimensions in space and 1 dimension, which is the time. So we are living in a 4-dimensional world, and there is nothing more basic that you could think of. And once you formalize it, which is what OPM did, you can really use this to express, as we have seen, systems and phenomena in any domain and at any level of complexity. And so if people adopt this way of expressing, there would be a lingua franca that people can express themselves and also understand what others do without having to adapt to different ad hoc notations.
Okay, thank you very much, Professor Dori, for your time. It was a pleasure.
You're most welcome.
Thank you very much. Thank you.
Bye-bye.